All right, let me make sure that this is coming through, okay? Looks like it is. Let me that this is Yeah, okay, cool. All right, welcome everyone. I tried to do this a moment ago but ran into a couple problems. Looks like we're finally set up. So I'm just going to dig right in. This is the first live stream I've ever done. Thought that R1 kind of warranted a live stream and the first one I've ever done here on YouTube. So hopefully you'll all bear with me here as we navigate this together here. Yeah, DeepSeek R1 just dropped yesterday. It's a model that is on par with OpenAI's O1, so pretty impressive stuff there. And we'll kind of go through some benchmarks today. I actually want to test it because I haven't really tested it quite yet. I believe I did get signed in. Yeah, so I did get signed into the DeepSeek app. Over here, you see you can click on this deep think and actually use the model. So pretty cool stuff. But yeah, so DeepSeek R1 launched yesterday. It's on par with OpenAI's O1 model. So we can take a look at. Actually, I opened it over here, didn't I? Wait, one of these. Yeah, here we go. Okay, so DeepSeek R1. There are a few different models you can choose from when it comes to their reasoning model, all the way down to 1.5 billion parameters, which means that the thing could potentially run on a typical household computer. 1.5 billion parameters is pretty much nothing, especially in today's standards. I believe their full-fledged R1 model is about 671 billion parameters to put it in perspective. But yeah, let's take a look at some benchmarks here. So the AIME, I believe that's a math exam, right? Either way, they outpaced OpenAI's O1 on this particular benchmark by a fraction of a point here, but also outpaces their 32 billion parameter model and mini and V3. It's kind of crazy when you add this reasoning component. The difference in scale you get with the accuracy of answers, like V3 is pretty good, right? It's better than GPT 4.0 in a lot of different categories, but we see that DeepSeek R1, adding that reasoning component, you about double the accuracy in this particular benchmark, at least. Coding wise, it looks like OpenAI's O1 outpaces it just a tad, less than a full point here. So coding wise, O1 may have a slight advantage here, but it does outpace their other reasoning model and OpenAI O1, and of course their V3 model. GPQA, this is the benchmark I really am interested in nowadays. These are questions you can't really Google proof, or you can't really Google. So a lot of people are like, what if the model has been trained on the data set, which is a very valid concern. These are questions that you can't really just train a model on. This kind of tests its actual intelligence and general intelligence, if I should say. But it does miss the mark when it comes to comparing it directly against O1 just by a few points here. But it is better than O1 Mini and, of course, V3. All right, taking a look at this Math 500 exam. It outpaces OpenAI's O1 yet again on this particular one. Crazy stuff. MMLU 90.8 compared to OpenAI's O1 at 91.8. So about a point lower there. And then the SWE, the engineering benchmark, looks like we're at 49.2. So just a few point, or not even a full point ahead of O1, but it is a victory nonetheless on the engineering side. So what makes this model really important is how cheap the thing is to run. Not only is it open source, so we can peel back some layers and actually see how the model works, what its biases are, etc. I think open source is kind of the way to go. It allows everyone to have information access and kind of understand, are they getting the right information? Are they getting biases? How is this model trained? All this different stuff. But another thing that is really important here on how the model actually works and why it is so cheap, and we'll talk a little bit about the API. So if you're a developer or you're actually wanting to start using this and use the API, I'll go through those specific numbers. But taking a look at the models here, R1 0 and R1 671 billion parameters. So crazy stuff. I believe that is pretty close to the V3 model that they just released, about 671. But the crazy thing is it activates about 37 billion each call, right? So you don't have to call all 671 billion parameters every time you make an API request or you're talking with a model. It does kind of this segment calling, and it makes it way more efficient than what we see with other models that may try to pull in all parameters. And it has a 128K context length here as well. And then another very important call out is we see that there are a few different models you can choose from here. So R1 Distill, this is insane because now you can have a reasoning model that is only 1.5 billion parameters. Think about that, 1.5 billion parameters compared to the 671 billion total parameter model of the full-fledged one. I will say I've seen a few people running this on a set of Mac Minis, so if you get a few of those, you can actually run R1 quite well apparently, which is nice. But then again, the cost to compute is pretty cheap, at least for now. I'm sure that is going to change as we get closer to AGI and beyond. I kind of foresee compute drying up a little bit, but for now, you can actually rent like an H100 for, I think it's like $1 or a few dollars maybe a day or something like that. It's really cheap, versus trying to buy an H100. They kind of break down all the other benchmarks here as well. The MOE architecture, which is how it's able to do this calling here, making it very cheap. But it goes through a couple different benchmarks here and comparing itself to other models. It's kind of crazy how effective Claude 3.5 Sonnet is. Like sometimes I forget about that one. I hope they're kind of cooking up some sort of reasoning model or something like that, as I think they could really kill it. I think their CEO just made an announcement saying that over at Anthropic, they plan to release a better computer use model at some point this year. So interested to see that as well. But yeah, we see that it does pretty well when we compare it to other models here in the various benchmarks it has laid out. Distilled model evaluations. This is really cool because we get to see how these smaller models compare. Of course, the 1.5 billion parameter model, it is a tiny one, but it's still pretty good when it comes to math, when it comes to the Google proof questions. I'm not sure exactly where like 4.0 lands on some of these, but 1.5 billion parameters, and it's a 954 on code forces. Wait, yeah, I want to see this real quick. Um, wait, let's see where that is exactly. Where do I go to the? Oh, okay. But where's the Is this it, right? I think so. So yeah, I'm pretty sure, what is it? Didn't O3 get like 2700 or something like that? Which would put it at like, let's say like 140 or so. But either way, I mean, having where does 900 put you? I mean, I'm just trying to see how effective this 1.5 billion parameter model is, and then we can go through some other things. Let's see, 1.5 billion, 900 actually. I mean, it's not that great. Yeah, I mean, they put you at like the 79,000 mark. Which, I mean, having a model on your computer or potentially maybe even your phone. I'm not sure if you can run 1.5 on your phone. Um, I think you can. Like 1 billion parameter models don't, that doesn't seem that insane to be able to run on a phone, but I'm not entirely sure how it works or if they have the specific file you need to run it on a phone. That is something I need to do a little bit more digging on. But yeah. Okay, so Christian Cooper shared this video, and I think it's super cool. Let me check this real quick. Okay, just wanted to make sure. Does this come through? There's no audio, but he said make a like video demonstrating the Pythagorean theorem. Look at what the thing does. This is mind blowing to me. Sorry, it's a little cropped. Wow. And then this one really blew my mind, right? So Christian also did this where what did he say? Okay, now let's really swing for the fences. I told DeepSeek how I understand quantum electrodynamics to work and to render this visually. Begin by slowly fading in the whatever. I mean, I'm just thinking of the potential here when it comes to learning and understanding various topics. I'm a very visual learner, so this would be really helpful for me depending on what I'm trying to learn. But taking a look at this here, I think this is super impressive. Imagine if just with a simple prompt, you can create entire like educational videos that have charts, have visuals, all that sort of stuff built within it. I think this is really cool stuff. So check this one out. Oh, hit pause. Isn't this nuts? Oh my goodness. That's it. Wait, no. I think the text is a little off or upside down, but this is just the beginning. Like I love this stuff. Being able to visualize different topics like this is going to be huge. This one just blew my mind though. Make a educational video on the Pythagorean theorem. Boom, here you go. So yeah, that is a little bit of a sneak peek there on R1 and its capabilities there. The API, based on it being this MOE architecture, how you don't need to call all 671 billion parameters each time you make a request. So the cost of using this model is super cheap. I saw a screenshot yesterday. Someone had been using it and made about 70 calls and had a total of 6 cents that they had to pay for it. But yeah. So wait, what was I gonna do? Okay, so the let's see. I believe it's like 97% less than the O1 model, right? So output API price, DeepSeek R1, look at this, 2.19 compared to O1's 60. 0.55 compared to 15. 0.14 compared to 7.5. These numbers are insane how cheap this thing is. 14 cents per 1 million tokens. My goodness. 1 million tokens is an astronomical number. I'm trying to think of that math because like I've been trying out Claude's computer use a little bit, but it's a little expensive. And it's not I mean it's not that great quite yet. But like I said, they're working on a new model they should be coming out with soon for that to make computer use better, where you can actually run it inside of your own computer. But I'm trying to think. I put like $40 in it, and after about 160 tokens, it uses about $2 to $3, I think, somewhere in that neighborhood. This is just insane, the cost difference on this thing. Did we go through this? Yeah, so we went through this, comparing it to the other models. Assuming this is like a one-shot test on what it is. Yeah. Okay. We kind of already went through some of the benchmarks, so I do want to test it out and see how effective it is in answering questions. So, let me think of some questions. So, there is a farmer that is planting crops, and he says, I can't go to the store right now as wait, hold on, let me think. Actually, let's try something like this. There's a farmer that is planting crops, and he says I can't go to the store right now as my um where can I take this? Let's try this one. I've seen this question before on just like testing the abilities of models. Let's see if this one works. There's a surgeon that says, I can't operate on this boy. The boy is my son. Who is the surgeon to the boy? Okay. Sorry, that took me a minute to come up with something. Okay, so I need to figure out the riddle. There's a surgeon who says, I can't operate on this boy. This boy is my son. Who is the surgeon of the boy? First, the key point is that the surgeon can't operate on the boy because the boy is their son. The obvious answer might come to mind that the surgeon is the boy's father. But wait, the riddle is probably designed to challenge assumptions. Maybe the surgeon is a woman because sometimes people assume surgeons are male. Oh, wait. True, 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 true. I mean, hey, wait. Hold on. Let's try this. Let's try this again. Man, let's try this. Wait, look. There's a surgeon. The man says, I can't operate on this boy. This boy's my son. Who is a surgeon to the boy? So the surgeon would be the father because I said it's a man, right? And it says the surgeon is the boy's mother. It's kind of crazy how long these monologues go, these internal monologues. Wow. Okay. Oh, okay. Let's try this. A plane crashes or wait, on the border of U.S. and Mexico. Okay, so the riddle: the plane crashes on the border of US Mexico. The question is, where do you bury the survivors? First, I need to parse the question carefully. The key words here are plane crash, border, bury survivors. My initial thought is that this classic riddle is meant to trick the listener. The trick usually lies in a play on words or common assumptions. So when they ask where to bury the survivors, my first reaction is consider the location of the crash on the border between two countries. Maybe the answer has to do with which country's jurisdiction the crash site falls under. But wait, the border is a line, so technically parts of the wreckage might be in both countries. However, that seems too literal and not likely the answer intended. Then I remember that many riddles rely on a twist. The keyword here might be survivors. If there are survivors, you don't bury them because they're still alive. Burying is for the deceased, so the answer is you don't need to bury survivors at all. That makes sense. The riddle is designed to make you focus on geographical aspect, US versus Mexico, and overlook the fact that survivors would need a burial. So let me check. Setup mentions border specifically. Could there be another layer? Maybe something about international laws, customs regarding burial? But no. The core of the riddle would likely be wordplay around survivors versus victims. Survivors are alive, so they aren't buried. The trick is to catch the listener into thinking about the location when the real answer is you don't bury survivors. I think that's it. The riddle is a play on common assumption that plane crash results in fatalities, prompting the listener to consider where to bury the dead. But by specifying survivors, it subverts that expectation. So the answer is that you don't bury survivors, you help them instead. Therefore, the correct answer is that survivors aren't buried because they're alive. Oh my goodness, that is so good. Okay. I really want to see if O1 can get this right. I don't have O1 Pro, but I do have O1. And I am curious. So, I'm I'm gonna put it over here. Of course, I ask my. Oh well, it should be fine. Um, yeah, let's do it. Okay. Hope you all can see this. Let me just double check. Cool. Okay, so you can see it. Um. Oh my gosh. Okay, so O1 got it too. All right. I don't have O1 Pro, but it probably would get it. I don't know. Okay. Another thing that I want to really drive home here is that V3, which is, DeepSeek, their 4.0 response, ChatGPT 4.0, they released V3, right? Which was about like 25 days ago or so. What, like a little over 3 weeks, not quite 4 weeks. They released V3. Yeah, so on December 26th, they released version 3. And not only 3 weeks later, we have this reasoning model that outpaces O1 in a couple different categories. So I'm very curious what else they might be cooking up over here at DeepSeek and maybe other labs. It's a huge victory that they are making this open source, and really wanted to drive that home as well. Like, this is an open source model. You can run it at home. We can peel back different layers, see what its biases are, see how it works, better understand and build on top of this stuff. So I am super impressed with DeepSeek R1. Let me know your thoughts. I think that's going to be everything today. If you did tune in, I appreciate you, but I'll be back here very soon with some more stuff. All right, take care. Bye.